Here is a complete test paper with tips to solve examination style questions. I hope the video will help you not only prepare for the test but to get excellent marks as most of my students are getting. Let's enjoy this journey of learning. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are taking a complete test paper on the second unit, which is equivalent expressions. Pre-calculus MCR3U functions. That is the name of the course here in Canada. So very first question here is to expand and simplify part A and B. So I've taken slightly difficult questions to begin with because normal expand and simplify questions you can do. Sometimes the problem occurs when you have three terms to be multiplied as shown here. So part A is 2x minus 1 times x minus 1 times x plus 2 minus 3, and B is x minus 2 times x plus 2 minus x plus 1 whole square. Here you will also learn how do you apply the known formulae to do it faster and easier method of doing it. Next question here is based on expressions which are not equivalent. So you'll understand and appreciate what is the difference between equivalent and not equivalent functions or expressions. So the question here is determine two non-equivalent polynomials, so these are functions f of x and g of x, such that f of 0 is equal to g of 0 and f of 3 is equal to g of 3. What you need to understand here is that if there are two given functions, they may be equal at couple of points, but that doesn't mean that they are equivalent. Equivalent means that they are equal at each and every point. That is to say, that their graphs will overlap. So I hope you understood the concept. So with that concept in mind, you should work on this particular test paper. So let's begin with answering, and then I'll share with you many other questions which follow, right? So there are many questions to follow with some factoring skills. Perfect. So let's begin with the very first question and its solution. I want you to pause the video and also solve the questions yourself and then look into my suggestions. So the very first one is we have 2x minus 1 times x minus 1 times x plus 2 minus 3. Now in such cases, you should actually multiply any two of them first and then with the third one. So you should multiply two of them first. Let us say these two will be multiplied first, right? So in that case, what do I get here? I get this as 2x minus 1, and then apply the distributive property, right? X times x is x squared, plus write numbers before the variables, correct? And so we have the expansion as shown here, correct? That part is clear to you. Now we'll simplify what is there within the square bracket. Purposely, I'm using different brackets as it makes things very clear. So the idea is for some of you who are lagging behind, they can now catch up and understand the techniques of doing the work correctly. You get the idea. So now we are going to multiply with 2x minus 1 the terms in this square bracket. We should get 6 terms now, right? So binomial, when being multiplied into a trinomial, will give you 2 times 3, 6 terms, which can be simplified, of course. Multiplying with 2x, x square, will give me 2x cubed, correct? Then with x, it gives me plus 2x square. Minus 2 will give me minus 4x. Now with minus 1, the signs will change, and you can rewrite all the terms in the square bracket. Make sense? And remember to include minus 3. Now it is time to combine the like terms once again. So you get 2x cubed. Now x squared terms, 2x squared minus x squared, right? So identify the like terms. You get the idea. So once you identify the like terms, it becomes slightly simpler, right? So I have identified, and now I'm going to write down. So 2x squared minus x squared will give me plus x squared. Minus 4x minus x will give me minus 5x. And then plus 2 minus 3 gives me minus 1. Space them out as I have shown very clearly. So let it be neat like shown here. This helps. So I hope you have got some tips to how do we simplify, right? So that was a standard way of doing it. Now, looking into the second, I'd like you to pause the video, expand this. We have x minus 2 times x plus 2 minus x plus 1 whole square. Purposely, I've taken this particular example to teach you another technique. Well, some of you may remember few formulae. What is a plus b times a minus b? So a plus b times a minus b is equal to a square minus b square. Do you see that? So the first combination, which is x plus 2 times x minus 2, we can use this and it saves you time, right? Now the second combination, which is kind of a plus b whole square. So a plus b whole square is actually a square plus 2ab plus b square, right? So the second one, as you can see here, is a plus b whole square, where a is x and b is 1. Simple as that, right? Just to complete the formula here, in case it is a minus b, then this term will be minus 2ab. I'd like you to make a note of these formulas moving forward. So treat this as a lesson, right? Combined with test practice. That will help you to really score very good marks, as most of my students are doing. Well, in case you want to learn from me, you can always send an email on the address given and follow this success path, right? Achieve your goals with confidence. Let's move on and see how do we simplify this second expression, right? So let me rewrite it, which is x minus 2 times x plus 2, and then we have to take away x plus 1 whole square, right? Now we are applying the difference of squares here. A minus b times a plus b is a squared minus b squared. Do you see that? I'm writing 2 squared just to show you we have applied the formula, right? And here we're making a square bracket because all the terms will come after minus within a bracket, easier to write. Then we'll open the bracket, correct? So it is a plus b whole square, which gives us a square plus 2ab, which is 2x here, and b is 1, so 1 square is 1. Makes sense? Now, it's a good idea to open the bracket, right? So x square minus 4 minus. When you open this bracket, all the signs will change. Follow this method to avoid mistakes and get 100% marks, right? So x square minus x square, like terms, is 0. Minus 4 minus, so minus 4 remains here, and we have minus 2x. It is good to write the terms with powers of x in ascending way. And minus 4 and minus 1 is minus 5. You see that? So that is how you're going to solve this, right? So you see x square and x square kind of cancels, right? So we do not have x square in our terms. And we combine minus 4x with minus 1 to get a result. So I hope this is absolutely clear, right? So we have done the first two. Now let's talk about this equivalent and not equivalent functions. So what we were doing were expressions. You get an idea. Those were the expressions, right? Now this is a function. Determine two non-equivalent polynomial functions, right? So two non-equivalent polynomials, right? Polynomials have continuous graph, f of x and g of x, such that f of 0 is g of 0. Let me rewrite the conditions. So we want two different functions where 2 points are common. One of them is at 0, right? So, and the other one is at f of 3. So in such cases, my recommendation is to look for the simplest functions, right? So I'm going to take a parabola, which is like y equals to ax square, right? And y equals to kx, a line. Do you see that? So these are the functions which I'll consider. Let me sketch and show you what I really mean to say. So parabola is something which opens, it could open up or down, but I'll take one which is simple, which opens like this. Okay. Right. And I'm taking a line which crosses through, but has two common points. Let this line be like this. You get the idea. And let's graph it on it. Let's say that is the situation. Now it looks like that the line intersects the parabola at 2 points. Now we are given that these 2 points happen to be at x equals to 0, right? So at 0, I'm taking 0, 0, right? And the other point common is 3. So I'll write value 3 here. Correct? So that is x value. Now, what function is simplest for me? Well, y equals to x squared is simple. So if x equals to 0, in that case, I can write this as 0, right? So if I take y equals to x squared as my function f of x, right, it's a way of writing, that is function notation you know. Then let's find what is f of 0. So f of 0 will be 0. And what is f of 3? Well, f of 3 is 3 squared, which is 9. So this point should be 3, 9. Makes sense? So we have taken one function, which is x squared. What could be the other function? So let's take g of x as the other function equals to the line, right? So g of x is a constant times x, direct variation. So now we know, because it goes through the origin, well, b is 0, right? So I know it goes through point 3, 9. That is the second point on it. So if I substitute 3 for x, then what do we get? So what is g of 3 equals to? Well, k times 3, right? And the value should be 9, correct? So that means that k should be equal to 9 by 3. 9 by 3 is 3 itself. And therefore, we can now write down the function g of x. You get an idea, right? So g of x is equal to 3x. Correct? So we have got our solution, right? So what is the solution for us? Solution is, for the given conditions, we have a function f of x which is equal to x squared, right? And the function g of x which is equal to 3 times x. In that case, we find that both these conditions are met. And as you can see, the parabola and the line only intersects at 2 points, and therefore they are not equivalent, right? So they are non-equivalent polynomials. Does it make sense to you? Correct? So I hope this whole concept of the unit on equivalent and non-equivalent expressions is coming clearer, right? Great. So let's move on and look into one of the difficult application questions which has been there in the test papers many times. So this time the question is, the two sides of a triangle are 3x plus 2y minus 1. The perimeter of the triangle is 9x plus 7y. Find the length of the third side. It's a good idea to sketch, right? So let's sketch this triangle. Isosceles triangle, right? So two sides of, it should be of an isosceles triangle. So two sides of an isosceles triangle. So make this correction. Is that clear to you? The perimeter is 9x plus 7y. Find the length of third side. Isosceles triangle means that two sides are equal. So we are taking these two sides are equal. Now we don't know what is the third side. So let's label this as ABC. So perimeter is sum of all the sides, right? So the perimeter is basically sum of AB plus BC plus AC, right? Now we are given two sides. Let us say these two sides are given to us. So we are given that AB is equal to, let's say, BC, and both of them are 3x plus 2y minus 1. That is given to us. Plus, we are also given that the perimeter is 9x plus 7y, correct? So we can now write down the equation. So perimeter is 9x plus 7y, and that is equal to AB plus BC, so which is 2 times one thing, right? So 2 times, you can write this as 3x plus 2y minus 1 plus AC. We don't know what AC is. We have to find the length of this side. Is it clear to you, right? Let us expand and simplify. So we have 9x plus 7y equals 2. Open this bracket, 6x plus 4y minus 2 plus AC. So we can find AC by isolating it, right? So we have 9x plus 7y minus 6x minus 4y plus 2, right? And that is AC, which we need to figure out. So let's combine the like terms, x values, 9x and 6x. When you take away 6 from 9, you get 3x. Y is plus 3y. The constant is plus 2, right? So that gives you the length of AC. Do you see that? So we got our solution, and that is that the third side is 3x plus 3y plus 2. Is that clear to you? Correct? So that is how we should be doing it. Note this correction, right? We are looking at the isosceles triangles, the two sides of an isosceles triangle. Okay. Now let's look into the next question, which is also an application question. Find perimeter of a square with area of 9x squared plus 6xy plus y squared. So what we are given here is a square. Perimeter is sum of all the sides, correct? We are given the area. So area is given to us. So what is the area given to us? Area is 9x squared plus 6xy plus y squared. So it is a perfect square. We can factor it, right? You identify that 9x squared is like 9x whole square, right? And y squared is given to us as y squared. The middle term is indeed 2 times 3x times y, correct? 6xy. So that means I could write this as 3x plus y whole square. Makes sense? So that means that each side is actually, all sides are equal, right? And each side is 3x plus y. Since we know each side, we can find the perimeter. Perimeter is sum of all the sides, or you can say 4 times each side, which is 3x plus y. So open this bracket, you get 12x plus 4y. So that is how you can find the perimeter. So that becomes your answer for the question. Make sense? Correct? So I hope that you are there with me in this regard. If there are any doubts, feel free to send an email on the address given, right? Let's move forward. And we have a very, very interesting question, which is f of x is given to us as a plus b plus c whole square and g of x is all that. Show that the above functions are equivalent, right? We have to show that this formula stands, right? So what can you do? Well, to show that, what we need to do is write down and simplify the fraction, right? So we are given f of x as a plus b plus c whole square. So let us expand it. It really means we have to do a plus b plus c times a plus b plus c, correct? And apply the distributive property. First multiplying with a, we get a square plus ab plus ac. Now with b, we get ab plus b square plus bc, correct? And with c, we get ac plus bc, right, plus c square. Now we can combine the writing squares first. We get a square plus b square plus c square. And see, how many ab's do we have? So we have one ab here and then one ab there, right? Similarly, you will notice that we have two ACs, right? AC here and AC there, and BC also, right? So as you can see, we can actually write here 2AB plus 2 AC plus 2 BC. Makes sense? So we get our formula, right? So it is a square plus b square plus c square. We can take 2 common and rewrite as given in the expression. Makes sense? So these are equivalent expressions, correct? These are actually equivalent expressions. Now, at this stage, I will also like you to see graphically or picturize it, right? It's very beautiful picturization. So I have again the same expression for you. So a plus b plus c whole square will make a model, right? We'll make a model to explain you this concept. So take this opportunity to learn and prepare for the test, right? So that is the whole idea. So this video is for my students who really want to learn, right? So let's say that this is a for us. This much length, right? So what I'm saying is this is a for us, correct? So I'm saying this is a. Now, let me say b is this much. It's not to the scale, right? So they say this is b and I could have made longer, right? Let's say this is b, right? And the last one here is c for us. So if you multiply a with a, you get a squared. You see that? B with b, you get b squared. And c with c, you get c squared. So these are the terms you have when you multiply a plus b plus c. Do you see this length is how much? This is a plus b plus c, right? And this length is also of a square, a plus b plus c. Makes sense, right? Now, when you multiply a by a, you get a square, b by b, b square, and c by c, c square. But if I do ab, right, this is ab, and this is also ab, correct? And here, we have c times a. I could write this as ac. So c times a is ac. You get the idea. And here, we have bc and bc. So you do prove that a plus b plus c whole square is indeed equal to sum of their squares, right? Plus twice product of individuals, right? ab plus bc plus ca. You get the idea. Very important formula, and many questions are based on this for expansion and simplification. That is why I've taken this example here. Now, let's look into some factoring examples. Okay, before there, I want to take another very important question. So this is an application question. G of x is 3x squared minus 11x plus k. Find possible values of k so that g of x can be written as product of two binomials. Therefore, factor the binomial. So what I'm trying to say here is this could be written as ax plus b times cx plus d, right? So we want to find the value of k that it can be written like this, right? That's the whole idea, where a, b, c, d are integers, right? Where a, b, c, d belongs to integers. Makes sense? Correct. That is factoring, right? So what could be the values of a? We are looking for g of x equals to 3x squared minus 11x plus k. Well, I hope you remember product and sum, right? So we are looking for two numbers whose product should be what? Product should be 3k, right? And the sum should be equal to minus 11. So when you add the two numbers, you get minus 11. Now, what could give you 3 times k? So we are looking for two numbers which when multiplied gets 3k, and when you add them up, you get minus 11. Well, look for products of 3. That is a good idea, right? So 3 times 4 is 12, for example, right? So if I have minus 12 and plus 1, it works for you, correct? So if I have that combination, how can I get minus 12? I can get minus 12 for k equals to minus 4, right? So think like this. It's possible if k is equal to minus 4. Makes sense? So that is the thinking, right? That is the thinking. So we say, well, k equals to minus 4 can help us factor this very easily. Now let us see how do we factor. You get the idea, right? So we have the answer here, but the thing is, and the concept, right? Let's factor now. So let's factor this. We have 3x squared minus 11x minus 4. We're looking for product and sum, right? Which is minus 12. So 11 can be written as what? Can be written as we said, minus 12x, right? Plus x minus 4. And here we can factor out 3x, getting x minus 4. And we already have x minus 4 here. And now that could be written as x minus 4 times 3x plus 1. Do you see how we have factored it? That is what it meant. So we are done the factoring also, and thereafter factor the polynomial, and we know the value should be k equals to minus 4. Well, this is one of the solutions, but we can have many other solutions, right? So we could have many solutions. I will like you to provide us with more solutions. Is that clear to you? Okay, great. Now we are coming to the question here where we'll understand how do we factor. Now in this particular example, I've taken 6 of them. Very simple to begin with, right? Group factoring, correct? We have difference of squares and many combinations are here for you. I'd like you to now pause the video and answer these. Perfect? So this is a major part of equivalent expressions where you do factoring of polynomials. Now here is the very first example. So we have 6a squared bc minus 4ab squared. Check the numbers first, 6 and 4. 2 is common, right? A, B, C. A and B are common, right? So A and B are common. You could factor them. If I take AB and divide this into the term, then we get what? Well, A and C. As far as numbers are concerned, 6 divided by 2 is 3, right? So 3AC. Now here we have 4 divided by 2 as 2. A by A is 1. So we are left with b, correct. So we have factored this. Let me rewrite this as 2ab times 3ac minus 2b. Now we cannot factor further, right? So we say it is factored fully. Clear? Okay, great. Can you do the next one? Now the next one is kind of important to understand, that we have terms which is 3 minus x. Now 3 minus x is same as minus of x minus 3. Do you realize that? So when you open, you do get minus x plus 3, which is same as 3 minus x, right? So that is the concept which is being used in factoring of the second one. So let's begin by writing, which is x times x minus 3 minus y times 3 minus y. Some of you might feel there is nothing common, right? But there is. We could rewrite this as x times x minus 3, change the sign, negative of negative being positive. So we get x minus 3 again. X minus 3 is a common factor, and therefore we could write this as x minus 3 times x plus 5. So factoring means writing as product of two or more polynomials, as we had just done. Done, right? Next set of questions, C and D. So we have now 4 times 2 minus a whole square minus 81. How will you factor this? This is not an easy question, right? Well, you will realize that 81 is 9 square. I'd like you to use this concept of a square minus b square is equal to a plus b times a minus b. We have used this concept in our very first question to expand, right? Okay, you see that the first term is basically, you can write this like 2 times, right? 2a minus 2 minus a whole square. You see that? And here we have minus 9 square. Do you understand? So you could actually write it in this factored form, right? So we can actually write this as 2 times 2 minus a plus 9 times 2 times 2 minus a minus 9. Makes sense, right? Open these brackets, and then you can write 2 times 2 as 4 minus 2a plus 9, right? 4 minus 2a minus 9, right? And combine 9 and 4, so we get what? We get minus 2a plus 13. And here we get minus 2a and minus 9, and this is minus 5. Is that clear to you? So that is what you get. Well, you can take minus outside and rewrite this also. So we could write this as 2a minus 13. Minus and minus cancel. Do you see that? And we have 2a plus 5. So that will be your final answer. The last statement could be tricky. So I'd like you to review and check, well, do you understand that part? Correct? So this is kind of very important to understand at this stage. We took minus, both sides common, and therefore we got everything in plus now. Perfect? Okay, great. Next one here is equal to, let's rewrite that. So we are given minus 25 b square plus 1, right? Rewrite this as 1 minus 25b square. So that is as good as 1 minus 5b whole square. Do you see that? And so you could write this in factored form, 1 plus 5b times 1 minus 5b. Makes sense? Not easy question, but these are what? These are the questions you see in the test paper, and therefore I've taken those for you, right? Not those easy ones which you have been doing, right? Next set seems easy, right? But you need to group them properly to factor. So here we have b square plus ab minus cb minus ac. Now you recognize that I could take b common, sometimes c common, right? Let's try this out. So from the first two, I could take B common, and then I could take C common. Okay, right. So let's take B common here. So we get 1 plus A, and here I take minus C common. I again get B plus A. So B plus A is what, sorry, this is also B plus A. B was B square, right? So B plus A is common for us, and we get B plus A times B minus C as the factored form. So when the four terms are given this time, we used grouping by twos. Last time you saw we used the grouping in a very different way, right? Now here we have three terms given. Next question, which is 4x cubed minus 6x squared plus 2x. Let's rewrite the question. 4x cubed minus 6x squared plus 2x. So x is common, so let's factor x out. So we get 4x squared minus 6x plus 2. So now we have a trinomial quadratic. 4 times 2 is 8, so we'll apply the product and sum concept. So we were looking for two numbers whose product is 4 times 2, 8, but the sum is what? Minus 6. So the numbers could be what? Minus 4 and minus 2, correct? So we could rewrite this as 4x squared minus 4x minus 2x plus 2. Makes sense, right? So now we can complete this by saying, well, amongst these two, 4x is common, right? So it is 4x which is common. So I get x minus 1. And here 2 is common, right? So minus 2 is common, x minus 1. And therefore we get a factored form, which is x minus 1 is a common factor. And here we have 4x minus 2, right? However, we see 2 is also common. We could have factored 2 earlier also, but now we'll take out 2 from the next term. So we have 2x times x minus 1 times 2 is common here, so 2x minus 1. Makes sense. Now you could have taken 2 common here itself when you took out x. Perfect. But if you have forgotten to do that, it's never too late. By the time you finish it off, you could do it, just as we have done this time. Both are correct approaches, right? There's nothing wrong in it. Important thing is to write the answer in the simplified forms, which is what we mean by saying factor fully. Is that clear to you? Perfect. So with that, we end our exercise, right? So I hope you've understood these steps to solve such questions, right? So that's the end of our series on test paper on equivalent expressions. Feel free to write your comments and share your views. If you like and subscribe to my videos, it'd be great. In case you want to learn from me, you can always send an email on the given address. You can begin learning any day, and then that is the success path. Gain the success with confidence. Thank you, and all the best.